68 was part of the in-class work, and we're taking a look at these two equations, y equals x squared, and also y equals 2x minus 5. If I want to graph them on the same set of axes, so my x squared is just the parent function, locator point at 0, 0. So if I go through and graph that right there, I'm just going to graph the first 5 points. It's going to look something like this. The other one is 2x minus 5. So if I start at negative 5, slope of 2. And once I get to this point here, this blue graph is actually growing faster than this linear graph, so they will actually never intersect each other. So label the intersection, there is no intersection, which means I cannot solve it graphically. If we take a look at what this means algebraically, what I'm going to do then is I'm going to use the equal values method. They're both equal to y. So I'm going to set them equal to each other. X squared equals 2x minus 5. To solve this one, I'm going to want to get everything over to one side set equal to 0. So x squared minus 2x plus 5 equals 0. From here, I have different methods of solving. So I could use the quadratic formula. I could use completing the square. I can't factor it. You can't factor it. If you tried, you're making a diamond problem, you'd have 5x squared, negative 2 on the x on the bottom. Nothing works here, so it cannot be factored. So my two options are the quadratic formula and completing the square. I don't care whichever way you want to go about doing it, you're going to get the same result either way. So if I would go through and do completing the square, I would have an x squared. With I have negative 2x's, I get a negative 1x on each side, which means I'm adding 1 to complete the square. My side lengths are x minus 1. I would need to subtract 1 to counter out the 1 that I added in. So I'm going to have an x minus 1 squared minus 1 plus 5 equals 0. So my x minus 1 squared, combining those is positive 4. Moving it to the other side gives me negative 4. I am now going through and taking the square root of both sides. So when I do that, I'm going to end up getting x minus 1 equals plus or minus 2i. So the square root of negative 4 is 2i. Now to solve for x, I'm going to add 1, so x equals 1 plus or minus 2i. So I have two solutions. One of them is 1 plus 2i, and the other one is 1 minus 2i. Those are my two solutions for this problem. Since this is a system of equations, that means I need to solve for both x and y. So if I know what my solutions are for x, and I have two of them, I need to figure out what is the solution then for each one for y. So if I look at this one first, 1 plus 2i, I can substitute into either one of these equations to solve for y. I'll take one of them and put it in for this one. So I'll just start off with that, just so I can show you what that looks like. I'll take the other one and put it in for that one and take a look there. So if y equals x squared, that would be y would equal 1 plus 2i squared. To square that, I'm going to make my generic rectangle. 1 and 2i, and 1 and 2i. I get 1 there. 1 times 2i is 2i for both of these. But now this box right here is going to be 4i squared. 4i squared is 4 times a negative 1, which is negative 4. That means that my answer here is going to be 1 plus 4i, because these are like terms, minus 4, which simplifies to negative 3 plus 4i. So when my x value is that 1 plus 2i, my y value is negative 3 plus 4i. That is the coordinate point, or the x and y value. I'll get more to the idea of the coordinate point here when we talk about C in just a minute. Now I'm going to take a look at this blue one, 1 minus 2i. And then instead of doing the same thing with the generic rectangle, I'm just going to substitute in the other one so we can see what that looks like. So y equals 2 times 1 minus 2i minus 5. Distribute the 2, and I get 2 minus 4i minus 5. Combining like terms, I'm going to get negative 3 from the 2 and the negative 5 minus 4i. So the other coordinate point, when my x value is 1 minus 2i, my y value is negative 3 minus 4i. And those are the solutions to that system of equations. So problem C is just kind of having you think about, well, what could this mean? What is this for the whole problem? Well, when you think of a solution to a system of equations, specifically for graphs, you're looking at where the two graphs intersect each other. But as previously talked about on problem A, one of them was a parabola, and the other one was linear, and they did not intersect each other. So as of right now, we don't really have a way of talking about what it means or where they intersect, because they actually do not intersect each other. Again, these are imaginary numbers. They're values that make them equal, and it is true. So when we substitute these in to either one of these, it's going to be a true equation. The equation works out. As far as graphically, it does not work out because obviously they do not intersect each other. Hope that helps.